Now we're going like in the infinity land. Hide, right? Instead of okay, so I screwed up as usual. Okay, and it is all because of this stupid program, which I still can't get out of this. Oh my gosh, I hate this program. Even my old note thing that I had in 2010, Windows Journal was great. You hear that, YouTube? Okay, anyway, what's the matter? Are you okay? All right, so does anyone want to see anything from this, or are we forever hold our peace? Because this is definitely going to be on the quizzes, like an ability to do the thing. Yeah, just pick a number. 9, fine. Okay, that's why I got rid of it. Okay, so it's through pattern recognition. Okay, fine. Let's go look at number 1. And it's because of these patterns we were able to come up with this whole binomial theorem. We didn't come up with it, but just proving that it exists. But look at the patterns on the y and the x's. Y to the fourth, y to the third, y to the second, they go down 1. And then the power on x goes up 1, right? And it takes the place of having to take this to the fourth power and foil and do all this multiplying. My goodness gracious. Fourth power, that's not the fifth power. Oh my goodness. Seventh power, yikes. All right, so that would all be pretty rough doing it the long way. So that's what the binomial theorem does. And then it allows us to have questions like this. What's the coefficient if I were to multiply this out, this thing all the way to the seventh power? A binomial times itself 7 times listed out. Yikes. What would be the coefficient? Okay, well, the pattern was this. You had some C number, and it's 7C something. I got to fill in that blank. And then the next thing was you took 2y to the third times 2y to the third, and you raised it to some power times. And then, yes, this must be negative x squared. And by the way, that negative is not on the x squared. You square x, and then you slap a negative on there. I want you to know that that negative doesn't disappear. That is stuck in front of that x squared. So don't think that negative is part of that power. And then all I have to do is see that I need the y to the 12th, x to the 6th power, y to the 12th. Let's look at that second blank. What would this have to be so I would get y to the 12th? 4, power raised to a power rule. By the way, pattern recognition, we'd have to see the notes and look at your notes. But this would have to be a 3 then, because what's 4 plus 3, everybody? That's what happened when we were doing the binomial theorem. Those two powers that you raised each of the terms to added up to whatever the power on the binomial is. And then what's this number? Is it 4 or is it 3? Because this number always matches this number. They go up together. All right? So we're done. Now all I have to do is go to the calculator, and I only have this down in my head because of last hour we did this. 7C3 is 35. 2 to the fourth is 16. Careful, a negative raised to the third power is a negative. Now, another thing that students do wrong on this is they think this is some sort of subtraction statement, possibly. No, you take all of these numbers and multiply them together and get negative 560. And then it would be y to the 12th, x to the 6th, but they're just asking for the coefficient, which is just the number in front of that. So that is why you write what you write. Yes, real quick. Oh, no. Oh, what do you mean add the y to? You're not saying add 12 plus 6. Oh. In a way, yes, because the coefficient just means the number in front of, not the x's and the y's. So a real stickler math teacher, Tomorrow for the quizzes, it's, quizzes are multiple choice. So I wouldn't have negative 560 is one answer, and then negative 560 y to the 12th, x to the 6 is another. It's not what would happen. Not what would happen. Real quick, because we got to get to the notes. Absolutely. All right, let's move on. All right, and then 9-3 homework. He has his next week's test going to have all this stuff on it. Darn tootin'. I got to see some written work, man, on that. right? Really not going to be too much more. There's going to be a lot of connections. Really, the only added thing is factoring and then a new concept called synthetic division, which you're going to love. You know synthetic division? Oh, but you've seen it before? Nice. It's actually a very cool thing. Wouldn't say cool. I mean, I think it's cool, but I'm a nerd. Hey, good thing we didn't have to foil number 2. I always say I love fractions. I would hate foiling that out. That'd be awful. So hopefully you paid attention to the directions standard form as opposed to intercept. Hey, real quick, this is where your world's getting to. We're gonna start like factoring and then compare it to the graphing, which you already know, and then come up with some you know new concepts, but it's not really new, so it's really not going to be that bad as we finish off. Um, might have to do some log division. Long division can kind of be rough, but look at number 4. Seeing this graph, seeing the zeros, being able to find the equation from it, and then going in reverse. Um, and so on and so forth. So we'll see that next week. Just looking at the answers for this, definitely look for some multiplication success here tomorrow. We just don't want it a piece of paper test as people are quarantined. Everyone can get that done. We'll do one more little quiz that's online like we did last semester. Hopefully there's no cheaters. All right. Okay, so you got those I numbers. Remember, FOIL the I numbers, zeros or parentheses first, and something really nice happens. It actually makes it a lot easier. Thanks for standard form on that. 8 is super simple. 9, super simple. And answers will vary. All we're looking for is a negative leading coefficient, and then any zeros that match 2 having a minus sign, 1 having a plus. Anything goes on that. And then just having a multiplicity 2, 0 means the factor squared. All right. Don't forget about a multiplicity 3, 0 flattens out when it goes through, right? So remember that. We had that on last week's quizzes last Wednesday. Okay, so I just wanted to review that and remind you of that, the last homeworks there. I just stamped that one today that we just covered. That was 6, because we had the factoring one after the test. This is not on the quizzes tomorrow, the factoring. So we're going to have our little quizzes tomorrow, and then we're going to proceed on with factoring and some other concepts about this. You're supposed to get this done before, right? But we may have been trying to do too much, and you may have not gotten to that. So now this is the reverse. So I won't ask you this tomorrow. This is the basis of the test coming up here. So looking at this first one, we've got to remember this fact. And I'm going to go nuts right now because this drives me crazy. Students, why do I say good foilers? Anyone? Why do I say it though? It's because I'm sick of the nonsense. That's it. You want to get nuts? Let's get nuts right now. Here comes the jerk, Mr. Samuels. Here he comes, the one that you remember from August and September. How are we writing answers where this times this doesn't equal negative 12? Do you hear me? What letter is that in FOIL? F, O, I, or L? You have one chance. Like you have 4 chances. Which one is that? You guys, it's L, last. This is what the word FOIL means. First, outer, inner, last. People write answers that are nonsensical for factoring when last doesn't happen. Hey, what's first? Y times Y. All right, and then O and I are the middle term. This should not be rocket science. This should not take us any time at all to check, does 2y plus negative 6y equal negative 4y? I do have a problem with those that are saying you cannot do that. And that's where we got to make decisions. Are we an honor student or not? To be quite honest, you've got to do this. We've got to stop the insanity of, well, when I learned factoring, there was this way that my teacher showed me, and I'm a robot, and I'm just going to use that formula. No. A trinomial factors to 2 binomials as long as the FOIL checks out. And that's what you got to make sure you do. So, of course, we do have a GCF first, though. Always look for a GCF before you factor a situation. Same thing with this one. There's a GCF of 3x. Undistribute that. And actually, in the notes last hour, I just double checked myself. Did I do that right? 3x times x squared? Perfect. 3x times 10x, 30x squared. 3x times 25, yes. So I pulled a 3x out correctly. Good distributors are good factors. They understand those basics. And then this is a simple MA. It ends up being a perfect square trinomial. So we did spend a week or two on factoring and then solving by factoring. And, I'm not sure what was going on there. I know, I'm not even going to get into it. All right. It just was a rough little time, and hopefully we can recover from it. 5G pulled out. And then this is what is this called? No, not dividend. Difference of, anyone? Two, squares. Good FOILers, say it. Good factorers. G squared minus 16, G minus 4, G plus 4. Huh? What's G times G? G squared, sorry. And then 4G and negative 4G, what happens to those? Why can't we do that? I don't understand. I don't understand how this is hard. What's negative 4 times 4? That's why it's plus minus. What happens to the middle term? Cancels. All right. Don't understand why we are saying that is a tough situation. It's not. Oh, no. Okay, you're going to need me for this. We did actually have a real special set of factoring. This may have been one day of notes that we really focused on the sum and difference of two cubes. Okay, so let's try to remember this. First of all, what's the perfect cube of 27? What times what equals 27? 3. So you assess and find out. Okay, fine. 3x times 3x times 3x equals 27. What's the perfect cube of 125? The notes are obsessed with that number today. You're going to see that 3 times. So here's what happens. By the way, good FOILers, this is not a FOIL, though. When we check, there's going to be 6 multiplications. You guys remember that this is a binomial times a trinomial? Did you say something? Did you say a word that starts with S? No, I thought maybe you were saying something. What were you saying? Nothing? I thought maybe you were saying something about this. Then remember the word that starts with S that helps me on this question? Yes. Nice. That's what I thought maybe you said. Huh? Okay, let's finish this off. Binomial times trinomial. Anyone know what A and P is? Because he's right on the first two. Same, opposite. Who said always positive? Nice, Matt. Good job. Okay, so here's how it goes. And by the way, it's because of good FOILers, good factors, because when I write my answer, I'm going to check it. All right? First thing you do is you take the perfect cube of each one of the parts. That's why I wanted to assess this. Is this a sum of two cubes? Yes, it is. And then the S is same. So what does that mean I put there? Plus or minus? Same as the beginning, so it's plus. Now, you're going to be mad at yourself for you making this complicated before. All right, now hopefully you think yourself as a way different person back in September and October. Because the next part is, right here, is this squared. This times itself. What's 3x times 3x? So this is 9x squared, and then let's stop and stop the insanity. Stop writing answers that make no sense. Why is he yelling? Because this is not as hard as you made it. What is 3 times 9, x times x squared? What does that become? 27x cubed. The answer has to, good FOILers say it. Your answer has to make sense. It's got to be what multiplies to be the question. And this is what did not happen. It was a major destruction. People put in answers that had no clue or no context to what the question was to begin with. You did not become a good FOILer and a good factor. This did not occur. All right? And then let's go right here. All it is these two multiplied together. This is the pattern, and it works. What's 3x times 5? 15x. And now, what do I put here? Opposite of the beginning, which means what? Negative. And then you were right, always positive. And then this last term is just this term squared. What's 5 squared? And I'm going to prove it because this is the one that usually went wrong. What is 5 times 25? Lo and behold, it's what? 125. Good foiler, say it. This is why we say it. Your answer has to make sense. You're doing the opposite of multiplication. So to check your answer, you multiply. All right? Arrgh. Okay, let's get different colors here. And then let's watch what happens with the other stuff. Hey, what's that? What's 3x times negative 15x, just for giggles? Negative 45x squared. Hey, what's that? Positive 45x squared. What happens to those? Cancel. That's why, good foilers, good factors, that middle term is gone. And then one more. What's this and this? They are opposites of each other. Those cancel as well. So it's not good foilers. This isn't really a foil. Foil implies 4 multiplications. But that's the discount double check for factoring that correctly. Now I know I factored it correctly, and I can be at peace with myself. Okay, so let's do another SOAP. First of all, there's a what on this. We're going to go fast. GCF. And you do want to take out negatives. You always have been factoring. I always like having a leading coefficient that's positive. So you definitely want to take that negative out. And here we go again. So I said we're going to see 125 a lot. It's okay. Oh my, what happened? Anyone just notice that? Uh-oh. Ooh, school be canceled. Well, I think we're having an electricity issue, like in the school. Hopefully we'll end up being okay here. Okay, what goes in the first set of parentheses? For d cubed, I put what? D. For 125, yet again, I put what? 5. And it's same. Then what do I put here? D squared. Because what's D times D squared? I'm getting nervous. We're getting some light flickering here at Lockport. All right. And then opposite, which is what? Plus. And then what do I do with the 5 and the D? Multiply. And then the last term is always positive. What's the last term? If you don't put 25 here, you're missing the whole point. And then this is at least what we check. You know, D times D squared is D cubed. Yes. Negative 5 times 125 is negative 125. These were the things that were not happening for those that did not embrace or learn the factoring. All right, and then these stick out like a sore thumb. So factoring by grouping, if you remember, how many terms do you count on this? 4. And then I'm going to reverse back and look at all the notes that we have so far. So when you have 2 terms for factoring, you might have a sum or difference of cubes, or you might have a difference of squares. And that's part of what your mind has to look at. You know, so when I have 2 terms, it's maybe those possibilities. Always look for a what, though, no matter what. GCF, so that's it for every question. And then these other 2 represented trinomials. And trinomials was that MA method. The only thing we're going to miss in today's notes is when the leading coefficient isn't 1. And then we had a harder factoring to do. And we'll hit that later or in other notes. So, but I just want to put your mind, you know, what do I have to have sectioned off and filed in my brain? 2 terms, difference of squares, different sum of cubes. 3 terms, probably MA. And then 4 terms, that's what I mean about sticking out like a sore thumb. When you have 4 terms, the only possible thing you could do is grouping. You might want to add something to this, nice little cutout from a book. You do literally group those first 2 and those last 2. So you force those parentheses on there with that plus separated in the middle. Then you pull this R out as a GCF, and you pull that S out as a GCF. And I want you to mark this up. Even though I don't like that they wrote it second, that is actually a binomial GCF. I always write that out in front. You get to pull this out as a GCF. That's why 2 become 1. So people that don't understand how A plus B just becomes one thing, that's the same thing as not understanding how this 1R is out in front of the A plus B. All right? It's a GCF, a whole binomial GCF that you get to yank out in front. All right? So that's what this is. That's why there's only 1 there, just like there's only 1R right there as a GCF. So I did cover that back in the day and called it a GCF. But then, I think things get lost. All right, I don't think I have to do both of these because really something similar happens in both. So I'm going to speed this up. Last hour we kind of went to the bell, and I don't want to do that. As they were putting their bags away, I'm trying to furiously finish the last one. But very important. This is a must. Notice what I did first. That minus must become a plus negative. And then you must force your parentheses like this and like this. That plus stays in between these. That's what I don't like about the messiness of what students do wrong on this. All right, so always make that middle minus sign a plus negative. Then you'll see exactly what happens with this. And this is the key for factoring by grouping working. Taking out a negative 9 so that you end up with the same set of parentheses. Oh boy. Oh boy. These are equal. That makes factoring by grouping possible in this scenario. And then I am going to write this the way I want to. That's really the bell? Are we over? What the heck happened there? The school's going crazy right now. Lights are flickering. I think it might be a ghost. Lockport's haunted. All right. So I pull out that x plus 7. That actually scared the heck out of me. Thought I was really doing bad with time. So think of that as a GCF so that you can figure this out and then go from there. Oh, by the way, x squared minus 9. Anyone? The square thing, he says. He's whispering the answer over here. I did x minus 3, x plus 3. Is that wrong? He said x plus 3 minus 3. Does it matter? No. Okay, so you do want to factor completely up at the top. Almost the same exact thing happens in the other example in this section. So I think we're good. So remember this, right? So 4 terms is factor by grouping. You're going to access that file. You got to put files in your brain and get this figured out. Okay, and then you could read all this. It's all going to happen. What? You guys remember the quadratic formula? You want to do the song? Remember? She's excited. The opposite of B, wrong. That's not the opposite of B. I just did the same as B. That's too much thinking about the song. The opposite of B plus or minus the square root of B squared minus 4AC. Anyone? All over 2A. Remember that? This is a last resort. This is if you cannot factor, not that you cannot factor. Hopefully you get to be a good factor. But if it's not factorable, and then you have to solve. Square root property. That's the test. I was joking with Adrian here that I have these tests randomly sitting up here. The solving by factoring, square root, and quadratic formula tests right up here. Be kind of funny to show those and see where were we at back in that day. That was an in class after being online forever. I didn't know what was going on at home and blah 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 blah. Hopefully we get better with it. We know there's a GCF, right? Okay, and then what you're left with is x squared minus 9x plus 20. There you go. And then this is what you access in your brain. What kind of factoring is this when you have 3 terms? Oh, it's the MA factoring. And if I'm not sure of that, I'll do the MA factoring and I'll check because I'm a good foiler, which makes me a good factor. What multiplies a 20 and adds to negative 9? What are the 2 numbers, class? Negative 5, negative 4, which means x minus 5, x minus 4. Good foilers, good factors. X times x is x squared. Negative 5x and negative 4x is negative 9x. Negative 5 and negative 4 is positive 20. This is usually what goes wrong in any factoring. The last doesn't work. You know, and that you can't write that answer. You have to go back and think about what you did wrong. Okay? Just doesn't happen enough. And then this was the what we use next. Anyone know what ZPP stands for? Z is a number, zero, product, property. Zero product property says I'm only writing this once. If this times this equals zero, either this equals zero, thanks computer program, or this equals zero, or this equals zero. And then you solve. This is the one, I told you that. I told you that in the first video, and then I ended the video. When we were reviewing, you know, that students miss this as being one of the zeros. All right? What you typing on your calculator over there? Huh? What do you got over there? You got a program or something, or to get these zeros? Huh? Oh, I hope not, man. This is a no calculator scenario next week. Okay, well, I hope not. I was just curious what we were typing on the calculator. All right, so x equals 0, 5, and 4. I'm not writing that zero product property anymore. I'm going right from 0, 5, 4, right? Remember that? Once you see the factors, you go right to the zeros. We're in honors, man. We should be able to figure that out. Negative 3x gives me x squared minus 25. Negative 3x. I think we should know that's x minus 5x plus 5. And don't screw up this 0. This is x equals 0. When I set negative 3x equal to 0 and solve, I divide by negative 3. 0 divided by negative 3 is still 0. When you're talking about graphing, this is what I mean. We're getting close to, this is going to be, I'm going to ask you to graph this. So what you'd have to do is factor, find the x-intercepts, and then understand the end behavior, right? Doesn't it end like this because it's a negative leading coefficient, right, everybody? So it's just like that worksheet number 2, I think, that had the zeros. It was in factored form, and then you graphed it. Well, now you're going to have to factor it and then graph it. But that's the point of you not missing this as one of the zeros. And then x equals 5, and x equals negative 5. That's where we're headed, right? That's Thursday/Friday. And then some other components. Synthetic division does have a part. Is that the bell? Okay. We're in a twilight zone right now. I'm not sure what's going on. Lockport's going crazy. I guess I should do these two. And then I think at the end I could just do one of the last two. Let me check. Yep. And then we'll have 3 more bells happen during that time. Okay. So I think we know there's a 4x there we can pull out. Come on, computer, you can make it. We're almost done this year. Minus 4x plus 6. Oh, no. I already know we got a problem. Because the only way I could factor this, and this is what I mean too, it's coming up. I haven't had tough factoring where the leading coefficient was different than 1. We'll take care of that later. All right, but it is a simple MA. What is it? Does something multiply to 6 and then those same 2 numbers add to negative 4? No. What do we need? Okay, let's get that first 0 done though. This has nothing to do with the quadratic formula. That's one of my answers. So, yeah. And then the next one, the opposite of b plus or minus the square root of, you guys, and that button on that calculator. What's a negative squared? Positive, because I still get people today put negative 4 squared and press enter under calculator. What's the calculator give you when you type that just like that? Negative 16. Anyone putting a negative 16 in this position, arrgh, that's how I feel about that. Drives me crazy. You're a button pushing, non thinking person. You got to stop doing that. Just like good foilers, say it. How are you writing answers that don't foil to be the question in the beginning? All right, so b squared minus 4 AC. Oh no, I already see the future here too. All over 2A. What kind of answer am I going to get here? A negative in the square root, which means what kind of answer? Imaginary. So we got some simplifying to do, so I need some space. 4 plus or minus square root of negative 8 all over 2. 4 plus or minus. Okay. I don't feel like writing this. Maybe I'll write it above. I have some space. You know this is a square root of negative 1 times 4 times 2, right? This always drove me nuts too, the ability to simplify a radical. So I can ask everyone this, what's the square root of 4? What's the answer? Square root of 4? So everyone can take the square root of 4 and get 2, but not understand how to simplify a radical. It's as simple as that. You want to break this down into a perfect square and then evaluate the perfect squares. By the way, what's the square root of negative 1? I. It's just we want to isolate that. We don't want to see it anymore. We want to get rid of it in a different way. All right, and that means that other square root of 2 is stuck in jail. Now, I really do like writing the I in the middle. You can write it on the outside. Our book that we did use the book first semester, if you remember. They would always write I last. Just make sure it's not underneath that radical. All right, that is actually mathematically, syntactically not good. So I always write it in the middle. And then one more thing. No, you do not just divide 4 by 2. You actually separate this into 2 separate fractions in your mind. That's really what's happening. It's 4 over 2 plus or minus 2I root 2 over 2. So that's how you simplify this, which is 2 plus or minus 1 root 2 times I. I did catch myself and say that correctly. I just switched the root 2 and the I, if you caught what I said there. All right, and then let's think about the graph for a second. How many times will this graph cross the x-axis then? Ooh. How many times will this graph cross the x-axis knowing it's a cubic that would look like this? Oh, 1. Why only 1 time? Do you remember quadratics when they had imaginary zeros? What did it mean about the quadratic? It never crossed the x-axis. We had quadratics with imaginary zeros, and it was like a quadratic like this. One that was going up that never hit the x-axis. That's how it would get imaginary zeros. So next Thursday, Friday, or next week, when you get this, there's only one x-intercept. And that's what that means. So kind of talking about what's going on in the future. Binomial, trinomial. That's as quick as your files should go. And by the way, notice these say equal 0. That's why these say solve. See that where it says find all possible zeros? Did any of these on the previous page have an equal sign, yes or no? No. So I don't understand why people solve these and write, crazy things for that. Right? 1027, I'm right where I'm at. Good. Let's move on. Right? Perfect cube of 8 x cubed. Perfect cube of there's 125 the third time. Okay, now what goes here, everybody? Come on. It's the first term squared. So what goes here, everybody? 4x squared. What's the sign? Plus. What goes here? 10x. Those two multiply together. Good. And then plus, always positive. What goes last? 5 squared, 25. And it works. At least check this and at least check this. That's usually what's wrong if you did this wrong. Is that right? Of course it's right. So the first thing is x equals 5 halves. Don't forget that one. Second one, I have never, ever, ever, ever seen this part factorable. As a matter of fact, this always has imaginary solutions. So what do I have to use? Quadratic formula. D opposite of b plus or minus square root b squared minus 4ac. Oh, I already squared 100 or 10. So 10 squared minus 4ac all over 2a, which is 2 times 4. X equals negative 10. I'm just going to get down to it. This is negative 300. 2 times 4 is 8. It's 100 minus 400, right? Oh, no. Okay, first of all, what's 300? A number. Isn't it 3 times 100? Isn't it 3 times 100 times a negative 1? What's the square root of 100, everyone? 10. So here's how this breaks down. Plus or minus, square root of 100 is 10. It's an I number. Root 3 is stuck inside. And then these are all divisible by 2. So negative 5 plus or minus 5 I root 3 over 4. You have to divide both parts of the numerator by 2, not just the outside part. All right, go ahead and put your stuff away. I'm going to finish the video. This just ends with a factoring by grouping question. And that's what letter F is as well. So go ahead and, get right. Is that bell for real? Add 10. You go ahead. You walk right out. Remember, tomorrow's a quiz is, and then that's it. And then you're only turning in the Chewbacca's on Thursday. But I want this assignment done. It just won't be turned in with the grouping. We'll talk about that tomorrow. You too. I think this is x plus 1. Ooh, you might want to watch the end of this. This is solving a squared equation. So watch the end of the YouTube video after I share it. I think everything you see so far is factoring by grouping. You're fine with that. Pull out the x plus 1 GCF. Oh, and then this one creates a problem. You do not want to use the quadratic formula on this, but if you did, b would be 0. So I guess it would be okay, and it would work out. First of all, you get x equals negative 1. Then this one, when you're missing a middle term, you actually just want to go ahead and use square roots. With the middle term gone, we can subtract 10 and divide by 3. And then we could square root both sides. 2 things to remember on this. First of all, plus minus. This is not what we should have to remember. We know a square root of a negative is an I. So I guess it will take that I out. The other thing is, this ended up being a bit of a mess that we have to rationalize. And then yet again with that other one, forgot the I. You can put it outside or next to this. Make sure it's not underneath that radical. And then you end up with this. Okay? All right. And that show